Hi everyone, welcome to the part 2 of the Missing Link series. In our previous video, we introduced differential privacy. We explained you the definition of differential privacy and sort of tried to intuitively grasp how differential privacy ensures or guarantees privacy. In this video, as promised, we will explain how differential privacy can act as a missing link between synthetic data and private data, or else another way to say it would be how differential privacy can ensure that synthetically generated data is also private. To see that, let's first have a look at an example. This is like an artificial example we have created. So this is CeADAR's website, and from CeADAR's website, what we've done is we have scraped names of all the staff members. And we have also assigned a random age for all these staff members. So there are around 107 people listed on the website, and there are these ages randomly generated. So what we'll try to do is we'll try to generate synthetic data from these ages, so that if we release this data, the real age of CeADAR employees cannot be known. One naive way of doing that is to create histogram of different ages in the dataset, of all the ages in fact, and then to sample from this histogram. So the counts here becomes the probability of the ages. So like from ages 50 to 55, you would have the highest probability of outputs. So we generate synthetic data by sampling from this distribution, and that is how we preserve the actual information in the statistics of the age also in the synthetic data. What that means is, the mean, the standard deviation, those kind of things of the synthetic age would be preserved, but at the same time, we would not exactly know what the individual's age is. Differential privacy takes this security a step further. It mathematically guarantees that the synthetic data generated here would adhere to some privacy restrictions or some privacy budget. And that privacy budget in differential privacy is usually known by the parameter epsilon. So greater the epsilon is, greater is your privacy budget. The second important thing about differential privacy is that most of the differentially private mechanisms actually add noise in some way or the other to the data. So there are different mechanisms to add noise. There is Laplace mechanism, exponential mechanism, Gaussian mechanism, I think, and many more. So adding noise sort of guarantees through mathematical proofs that the data would become differentially private. So what do we do to make this histogram, this representation of synthetic data which we created earlier, differentially private? And one of those ways is to add noise to each of these bins in the histogram. So in this slide, we show you what do these histograms look after the noise has been added to them. Have a look at the bin here at 32 and a half. So this bin, the red one represents the actual count in our histogram, and the others are our differentially private counts generated by adding Laplace noise to this original count. And when the privacy budget or our epsilon value is small, that's when the most noise is added. You cannot see that in one particular here, but if you look at all of these, you'll find that green ones are usually the ones which are the farthest away from the red ones. That's when our privacy budget is the smallest. So smaller the privacy budget, more is the noise added. And this is how differential privacy guarantees that the synthetic data generated would also be differentially private. But what if we add more features to our dataset? For example, let's also add salary in our dataset here. So in addition to a randomly generated age, there is also a randomly generated salary. Now, what would differential privacy do? The answer actually remains the same. You can uh, plot a histogram of both these variables together and add noise to each of these bins and sample from that. So this was the basic idea of how differential privacy and synthetic data generation can be coupled together. This was a very naive example, and many research papers or research works exist where much more sophisticated techniques of generating differentially private synthetic data are proposed. And that's going to be the topic of our demonstrator, which will be released soon. So stay tuned, and if there are any questions or any suggestions, feel free to contact us. Bye bye.